Hi everybody, Mr. McGivney here, doing a second day of graphing rational functions. So coming off yesterday, we had our general setup where we factored, we canceled, we found the whole, we had the vertical asymptote. Today we're going to take that a step further, we're going to add some pieces to it. So what we had yesterday was, we took our original equation, we factored, now after factoring, we realize here that for this problem, x cannot be 2 or negative 2. Now, a week or two ago, those numbers didn't mean much, but now we understand that they have actual meaning, and the meaning comes with graphing. So based on this, I can cancel, and we are left with x plus 4 over x minus 2. That is our new simplified equation. With that, we now know that the vertical asymptote is x equals 2. That is because in this situation, the restriction of 2 is what's left over in our denominator after canceling. So the vertical asymptote, that restriction of 2, doesn't work in the original, and it still doesn't work in the simplified equation. With our whole, the whole is what's canceled out. So in this situation, we canceled out the restriction of negative 2. If I plug in negative 2 plus 4 over negative 2 minus 2, that in this situation gives me 2 over negative 4 for a value of negative 1/2. So I got negative 2, negative 1/2 right there. All right, so this is really where we left off the other day. Right? We filled in the XY table, we found some more points, and we sketched. Today we're going to take it further and actually make some more rules to make our graphs more defined. Right, so we're looking at the horizontal asymptote. The horizontal asymptote is the end behavior of the graph as x goes towards both positive and negative infinity. All right, so there are three different setups. All right, so when the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is always y equals 0. All right, so I always tend to make this chart in my class. So if degree of denominator is larger than degree of numerator, it will always be y equals 0. Okay. When the degree of the degree of the numerator is more than the degree of the denominator, there is no horizontal asymptote. All right, so going in the reverse. Denominator is less than numerator. There is no horizontal asymptote. The last setup is when they're exactly the same. When they're the same, the horizontal asymptote is the fraction formed by the lead coefficients. Now, what I like to think about with some of these is, if I plugged in really large numbers, oh, my bad, I forgot to fill this out. When degree of denominator equals degree of numerator, y equals ratio of lead coefficients. Right now, so what I like to think about is when x is really large. So if I look at this example here, I have, if I factored x minus 5, x plus 1, I cancel, I have 1 over x minus 5. So imagine if you plugged in 1,000,000, 1 over 1,000,000 minus 5, 1 divided by a super large number in the situation gives us basically nothing. So the larger x gets, the smaller and smaller y gets as it approaches 0. Right? It's never going to equal 0, but it's going to get really close to 0. With the second one, if I factored, come on, work, x minus 5, x plus 3, I cancel, that leaves me with x minus 5. Now, what is x minus 5? X minus 5 is a linear equation. All right, so I got my y-intercept at negative 5. I'm going up by 1. I'm going down by 1. Looking right there at my visual, there is no horizontal asymptote. We're not approaching any number. We're just going up to positive infinity and we're going down to negative infinity. All right, that's what we got there. Now with the last one, all right, keeping it even simpler. Imagine I got rid of all this. If I just had 5x squared over 2x squared, they both have a degree of 2, so they have the same degree. So that means that our horizontal is the ratio of the lead coefficient. If you had 5 times 100 squared over 2 times 100 squared, that's roughly going to be 5 over 2. All right, think about it. If you have 500 over 200, if you have 5,000 over 2,000, right? In all these situations, they're going to simplify to be roughly 5 over 2, no matter what we plug in for x. All right, so there's our 3 rules that we have. So if we go back to our original problem, I look here, right? I got degree of 2, I got degree of 2, and the simplified degree of 1, degree of 1. Since they have the same degree, our horizontal asymptote is the ratio of the lead coefficients, which here, 1 over 1 for 1. So our horizontal asymptote for this problem is y equals 1. Moving on to some practice examples. All right, so what do I got here? Larger in the denominator. Denominator is larger than the numerator. Y equals 0. All right. Numerator is larger than denominator. There is no horizontal asymptote. They both have the same degree. So y equals the ratio of lead coefficients, which is 3.